Hello students, in this video of the determinants that we are going to learn the tricks series of videos. This is one among that. So here the trick follows for this particular determinant to find out is I can directly say the answer as 0. In fact, this also 0. And how did I do that? How do I know that the answer is 0? The trick lies in understanding this concept, skew symmetric. As we all know what a skew symmetric is, let us take an example. For a given matrix A, if I have this one, okay, if I do its transpose, what I'm going to get? Okay, the rows transpose definition, as we know, it says like row will be changed to the column. So first row is changed to 0 minus A. Similarly, the second row A 0 C, and the third, that is negative B, negative C, and 0. And if you pull that minus out from this particular matrix, and you can see that the transpose has made the given matrix A as negative. Check there. All the elements previously which was negative has changed to positive, and the positive has changed to negative. So it means my transpose of matrix is nothing but the A matrix, but that is negative of A. So in such cases, if it happens, we call such matrices as skew symmetric matrices. Okay, and what is its order now? So our determinant for any matrix 3 by 3, it goes like expansion, which takes a lot of time. Then how did I say that the answer is 0 for this one? And one more thing which we need to understand, the property of the skew symmetric matrix is the diagonal element must be 0. Remember, the diagonal element must be 0, and then the order is 3 by 3, odd order, then only I can say the determinant answer is 0. What are the two criteria that you see? The matrix should be skew symmetric, and the order, if it is odd, then I can directly write that matrix determinant is 0. That is the simple trick that you have to remember for a given determinant matrix or a given determinant questions. You just have to check whether it is given in the skew symmetric form and the order is odd, then definitely the determinant answer would be 0. Let us just work by taking some more example. Can we apply it while having questions related to the properties of determinant, basically involving the variables, which the students might at times find it very difficult. So we'll take some examples and work it out with that. I'm taking an example. Okay, this time I'm taking only the real numbers. Let us just take one matrix, which is 0, minus 47, 33. Okay, then I have 47, negative 33, 0, 0. Okay, this is 7 or this is 7, irrespective of what numbers are there. You just have to check whether the diagonal elements are 0. Yes, the diagonal elements are 0. The order is odd, and check the elements whether it satisfies the criteria of transposing will give us negative. Yes, positive is negative, negative is positive, positive is negative. When this sort of thing also satisfies, then you can say your matrix is a skew symmetric and the order is odd, so my determinant answer is 0. That is the simple trick. Now let us take one more question involving, as I said, the variables. Now let me write a matrix which contains the numbers which is not in the form of skew symmetric but can be converted. That is what we need to check it in this particular question which I'm giving you. 0, okay, we have 100, and here it is negative 43, 43 minus 32, and 0. Now if I go with the definition of skew symmetric, I can check over here it is not in the correct order. So what do I have to do? Do I have to transfer any, or do I have to interchange any particular row? Yes. And we know whenever we interchange any particular row, the value would be the negative for that determinant. Okay, so that is the reason I'm saying when I interchange it, the row 2 to row 1, I'm going to get like that, and this row, first row, shifts over here. Now you can check carefully, we've got what is required. diagonal element 0, and you check your all rest all elements are opposite, it means it is nothing but a skew symmetric matrix. Order is 3 by 3. I can quickly claim that my determinant answer is going to be 0. Isn't it very simple, students? So with this simple trick, you can work it out. The questions. I hope you like the video. Please like, share, and subscribe.